is lesson 5.5, write equations of parallel and perpendicular lines. You should be on page 319. Got a little vocabulary to start here, and let's talk about what the word converse means. The converse of a conditional statement interchanges the hypothesis and conclusion. A lot of vocabulary there. So let's review something from earlier in the year, I should say, where we talked about what a conditional statement was and what a hypothesis and conclusion was. Here's a conditional statement. It's an if-then statement. I used this earlier in the year. If you are a freshman at FHS, then you have first lunch. That statement is called a conditional statement. It's an if-then statement. The hypothesis of that statement is the if portion of it. If you are a freshman at FHS, that's called the hypothesis of your conditional statement. The conclusion is what I have highlighted in blue. Then you have first lunch. Now, the converse of that statement, you can see the word here, I'm going to circle it in blue, it interchanges the hypothesis and conclusion. So if I interchange, or that means switch, if I switch the hypothesis and conclusion, this converse would be if you have first lunch, then you are a freshman at FHS. This would be considered the converse of the conditional statement I had listed. Now, it's important to note the converse is not necessarily true. Like, this is a true statement. If you are a freshman at FHS, then you have first lunch. That's true, but when you look at the converse, that's not necessarily true. If you have first lunch, then you're a freshman at FHS. In fact, that statement's false, because if you have first lunch, you could also be a sophomore. So this is not true, even though the initial statement was. In Chapter 4, you learned that the statement, if two non-vertical lines have the same slope, then they're parallel. That was true. When lines have the same slope, they are parallel. The converse of that statement is also true. So in other words, if two lines are parallel, they have to have the same slope. So these two converse statements would both be true. If lines have the same slope, they are parallel. That would be a true statement. And if lines are parallel, then they have the same slope. That would also be a true statement. These facts can be used when we have problems where we are writing an equation of a line that is parallel to a given line. So, for example, they will have you do some problems like this, and here would be an example. Write an equation of the line that passes through this point and is parallel to the line y equals negative 1x plus 5. So here's the first thing. Do you notice the slope of this line is negative 1? Since this line has a slope of negative 1 and I want a line parallel to it, my new line must also have a slope of negative 1. Remember, parallel lines have the same slope. Now the next thing, I want this new line to pass through the point negative 2, 11. So remember, negative 2 is an x value and 11 is a y value. Take negative 2 and plug it in for x. Take 11 and plug it in for y. And you'll see I did that here. And then simplify. Negative 1 times negative 2 is 2. 2 plus b would equal 11. If I take away 2 from each side, I just figured out b is 9. So I know my slope is negative 1 and b is 9, which means my answer would be y equals negative 1x plus 9. That would be the line that passes through the point listed here and is parallel to that line. You notice they both have the same slope, negative 1. Let's talk about perpendicular lines. Two lines in the same plane are perpendicular if they intersect each other to form a right angle. perpendicular does not mean, like I always have students in class, I ask, what's perpendicular? And they say it's when two lines cross. No, it's more than that. It's when two lines intersect and they form a right angle when they intersect. I want you to look at these two pictures carefully of perpendicular lines. First of all, this first line that they drew had a slope of -3/2. Can you see here? I'm going to highlight it blue. They went down 3/2. Now in this picture, they drew a line perpendicular to the one listed here, and I want you to notice this perpendicular line makes a 90-degree angle. Look at the slope of this one, up 2/3. Let's compare those two slopes. This first line, which is also drawn here, had a slope of -3/2. The second line, which I will circle in green, which is perpendicular, had a slope of 2/3. Compare those two. You notice, if I take this slope and I flip it over and change the sign, I get that slope. So let me say it again. If I flip this over and change the sign, I get this slope. All right? Let me speak that in a more mathematical way. If two non-vertical lines in the same plane have slopes that are negative reciprocals, so think about negative reciprocals. Reciprocal means flip. Negative means change the sign. That's what I just said. If I flip and change the sign, if I have negative reciprocals, then those lines are perpendicular. The converse of that's true also. If two non-vertical lines are perpendicular, then their slopes are negative reciprocals of each other. In other words, if you flip and change the sign, that would be the slope of a line perpendicular to a given line. They will ask you to look at lines or equations of lines in the homework today and determine if the lines are parallel or perpendicular. So let's try that process here on this sample problem. First of all, line A. You notice line A is in standard form. I can't tell slope from standard form, so the first thing I'm going to do is I'm going to rewrite this into slope-intercept form. I'll take away 2x from each side. I'll divide by 6 to get y by itself. And I get, when I break this into separate fractions and reduce, I have y equals -1/3 x minus 1/2. Do you notice that for this first line, I put it here in blue, my slope is -1/3 for line A. Let's go to line B. You notice line B, this is in slope-intercept form already. Line B has a slope of 3. Now let's go to line C. Line C is also in standard form. I want to find the slope, so I'm going to take away 4.5x from each side. I'm working on getting y by itself. I'll divide by -1.5. When I break this into separate fractions and reduce, I get this equation in slope-intercept form. Can you see the slope is 3? Okay, let's answer the question now. Are any of these lines parallel? Well, parallel lines have the same slope. You notice line B and line C are both with the same slope? That means line B and C are parallel. So they wrote that here. They are well, that's for a different problem, so I guess I shouldn't underline that. I'm just going to put down over here, line B and C are parallel because the slopes are both 3. Now, are any of these lines perpendicular? Well, let's check. If I take a slope of 3 and I flip 3 over and change the sign, I get a slope of -1/3. Well, look right here. Let me circle it in green. This line has a slope of -1/3, which means line B is perpendicular to line A. So is line C. Line C also has a slope of 3. It would be perpendicular to line A. And I went ahead and wrote that up here. So that's how you check to see if lines are parallel, if equations have parallel lines or not. If you get the same slope, you have parallel lines. If your slopes are negative reciprocals, in other words, if you can take your slope and you can flip it and change the sign, if that gives you the other slope listed, then you know that those are perpendicular lines. They'll ask you in the homework for some word problems, determine whether lines are perpendicular. So they want me to find out in this sample story problem, the Arizona state flag is shown, lines A and B appear to be perpendicular. Okay, A and B, if you see in the book, they look like they're making a right angle. The question is, are they? That's the big thing. Are they? Well, let's check. Line A is not in slope-intercept form. I got to divide by 12, so you can see that I'm doing that here. I'm dividing by 12, and I'm rewriting this into slope-intercept form. The slope of line A, I'll highlight it here in green, is negative 7/12. Let's do the same thing for line B. In line B, I got to get y by itself. I'll divide by 11, and the slope of line B I'll highlight here in orange. Are those slopes the same? No, so that means these are definitely not parallel. Also, are these negative reciprocals? So if I take this slope, if I flip it and change the sign, I get 12/7. Is that the same as that? No, it's not. So these lines are not perpendicular. Okay? These lines are not parallel, and they're certainly not perpendicular either. Last thing, they will ask you to write an equation of a line perpendicular to a given line, and we'll try that down here in this sample problem 4 at the bottom of page 321. Write an equation of the line that passes through the point 4,3 and is perpendicular to the line given. Now, do you notice the line given has a slope of 4? So if I want a line perpendicular to this line, I got to take 4, flip it, and change the sign, which I wrote here. The new line would have to have a slope of negative 1/4 if it's going to be perpendicular to the line given. Let's start writing an equation. Put negative 1/4 in for slope. Okay, this line is passing through the point 4,3. Now, do you notice I do not know what B is? I know 4 is X and 3 is Y. So where you see X, put in 4, and where you see Y, put in 3, which I did here. Simplify, so I'd have negative 1/4 times 4 is negative 1 plus B equals 3. If I add 1 to each side, I just figured out B is 4. So my slope of my new line is negative 1/4, and B would be 4. And there's my equation then, y equals negative 1/4 x plus 4. I'm going to pause the video here. If you have questions about lesson 5.5, make sure you